Alright, so welcome to lesson 2 of the chemistry series with Excellent Simplified. And in today's lesson, we are going to be looking at matter. Now, please take note that at the end of all my videos, there are past questions on that particular topic. So at the end of this topic, there will be past questions on this topic. Let's get started. Now, matter. What's the meaning of matter? Matter is anything that has what? Mass and occupies space. If you are defining matter, those two things must be there: mass and occupy space. Anything that has mass and occupies space. Some books you see anything that have weight and occupies space. Please, I will say in chemistry, if you are defining matter, define matter as anything that has mass and occupies space. As we go on, you'll see the difference between mass and weight. Alright, now having known the meaning of matter, there are three main states of matter. I'm using the word main. Three main states of matter, and the three states of matter are solid, liquid, and gas. Solid, liquid, and gases. These are the three main states of matter. Now, these three states of matter, I'm going to be using this table to summarize them. Solid, liquid, and gas. Let's start from solid. Now, a solid has, in terms of shape, the shape of a solid is definite. What does that mean? This is the shape of the marker. If I drop it here on this desk, it's still as it is. It is as it is. The shape is definite. The shape is fixed. So the shape of a solid is fixed, is definite. You can always say, okay, this is the shape of this thing. Do you understand? You can always say, okay, this is book. You can always say this is the shape of book. So solid has definite shape. But coming to liquid, the shape of liquid is indefinite. Do you know why? The liquid takes the shape of the container in which it is placed. So for example, if you place a liquid in a bucket, the liquid will take the shape of that bucket. If you put a liquid in, say, a 20 liters rubber, it will take the shape of that rubber. Do you understand? So solid has a definite shape, liquid has indefinite shape, does not have definite shape. What of gas? Gas, if you put your gas in a gas cylinder, it will just be moving up and down. It does not have a definite shape. So the shape of gas is not fixed also, so indefinite shape. It is not fixed. So you can see it is only a solid that has a definite shape, a fixed shape. Now coming to volume, a solid has fixed volume, or it's a definite volume, meaning the shape of the solid remains as it is. The shape is fixed, it does not change. What of that of a liquid? The shape of a liquid is also fixed, because if I turn 10 liters of water from one container to another container of 10, it will still remain that 10 liters. It's fixed. The molecules are held together. There is no space between the molecules, so they are held together. Do you understand? So the volume is fixed. But gas, the volume of gas is not fixed. It's not always fixed, because it occupies the whole container. Do you know that you can put, let's say, a 5 kg gas in a 3 kg cylinder? You can actually compress it, put it there. But 10 liters of water, once it is filled, because that's a definite volume. But for gas that does not have definite volume, the molecules are just moving haphazardly, just moving from each other like that, just moving. As you can see from this diagram here, the solid has a definite shape, a definite volume. Here, there's no definite shape. It's taking the shape of the container. If you bend it like this, it will bend the container like this, it will bend. There's no definite shape, but it has a definite volume. But for gas does not have definite shape. It's just moving up and down. The molecules are just moving up and down. It does not have a definite volume also. Alright, now coming to compression. Can you compress solid? Like this book, can you compress it? No, solid cannot be compressed. So compression, let me use no here, cannot be compressed. Solid cannot be compressed. Water, like liquid cannot be compressed also. but gas can be compressed. Gas can be compressed. That is why if you take a 5 kg gas, put it in 3 kg cylinder, it will still enter, just that the molecules will now be close. And if you on your gas, to be very fast in reaction because the molecules are now close. But you can actually compress it, put it in a small container, compress it. But now try to compress water. Now try this. You can after watching this video, you can go and try it. Put a 10 liters of water. Pick another jerry can, another rubber that is 5 liters. Then try to pour all the 10 liters of water in the 5 liter container. Try all the magic you can, press it, do anything you can. You can see it's not possible. But if it's possible, let me know in the comment section the magic you use. It's never possible. So solid cannot be compressed. Liquid cannot be compressed, but gases can be compressed. Now diffusion. Diffusion, we are actually looking at movement of molecules from high concentration to low concentration. Now diffusion can actually take place in solid, but it is very slow. It is very slow. Take for example, if you have a red bar soap and a green bar soap and you join them together, you fix them together, you will discover that after some time, a long time, some molecules, the green color will diffuse into the red colored soap, and the red color will diffuse into the green colored soap. That is height, but it's very slow. Now diffusion in liquids are slow also, but faster than that of solid. But in gas, the diffusion is very fast. Take for example, if you spray your perfume in your body, just now it will spread to everywhere, that is very fast in gases. So diffusion is fast in gases. So we've looked at the meaning of matter, the states of matter. We've looked at the states of matter. From this diagram you can see how the shape of the solid is definite, the volume is definite, the liquid definite volume, but not definite shape, because if you bend this container it will bend with it. Now the gas does not have definite shape, does not have definite volume. The molecules are just moving up and down. Now the next thing we are going to look at is change of state. Now if you heat your solid, it will change to liquid. If you heat your liquid, it will change to gas. What is making this solid to change to liquid? The heating, right? As you're heating it, the molecules will acquire kinetic energy. Kinetic energy is energy of motion. Acquire kinetic energy, and they will start to move apart until you have a liquid. Now if it is heat that is causing this change, what if you remove the heat? What will happen? You agree with me that it will return back, right? So cooling can actually return this back. Now we're going to look at the change of states from solid to liquid to gas and reverse. Now if you look at this diagram here, up here, look at it carefully. Change of states from solid to liquid. Like you have your ice. The ice is changing to water, to normal, your liquid water, your liquid. That is called, you said the ice are what? Melted, right? Melting. I'm melting my ice. I'm changing it from solid to liquid. So melting is actually change of state from solid to what? To liquid. But now you agree with me, if you take that same water, that liquid now, put it in a container, put it in your fridge and allow it overnight or for some time, it will turn back to liquid. To turn back to solid. And you tell me that the water blocked. Some of you used to say that. Alright, now that change of state from liquid to solid is called freezing. It's called what? Freezing. Now that liquid, if you continue to heat it, it will change state from this liquid to gas. And that change of state from liquid to gas is called evaporation. We said the water have evaporated, the liquid have evaporated. They have changed it from what? From liquid to what? To gas. Evaporation. But now you notice this gas here can, if you reduce the temperature of the gas can actually turn back to liquid. That's reducing the temperature. If you reduce the temperature of this gas, like if you reduce the temperature, the gas can return back to liquid. And that process, that change of state from gas to liquid is called condensation. Now, how many of you have observed this? For those of you that used to enter your kitchen, if you're cooking, if you remove the cover, the lid of your pot, you see water dropping out from under the cover of the pot. Where is that water coming from? Now, first of all, as you were heating the content of your food, of the pot, the liquid evaporated, change of state from liquid to gas. Now, under the pot now, it now condensed, the gas now condensed. That is change state from liquid now, from gas now to liquid. That's condensation. So change of state from gas to liquid is condensation. Now, can a solid change directly to gas without passing through the liquid state? Yes, it's actually possible, but not all solids can do that. Before you tell me that if you burn this book, if you heat this book, it will change directly to gas. No, that's not what we're talking about. Now, solid, if you heat some solids can actually change directly to gas without passing through the liquid state. Now, that change of state from solid directly to gas without passing through the liquid state is called sublimation. It's called what? Sublimation. So if I heat this solid and it changed directly to gas, we say this solid have done what? Have sublimed. So sublimation is actually change of state from solid directly to what? To gas without passing through the liquid state. Not all solids can do that. Some solids can sublime, some cannot sublime. Examples of solids that can sublime, we have ammonium chloride, we have iodine, we have dry ice. We have many of them, but a video will be dedicated for that. I'll talk more about that. All right, so sublimation, that's that. Now, change of state from gas directly to solid is deposition. So if a gas changes directly to solid, we call it deposition. Now we've looked at we've looked at the meaning of matter, we looked at the states of matter, we looked at change of states. Now the next thing we're going to look at is physical and chemical changes. This is exam concentrated area. Now please take note that this video is a series video. It covers chemistry series from starting of chemistry to the end of chemistry. So if you've not subscribed to my channel, please click on the subscribe button so you don't miss out. Please like this video also. Subscribe so you don't miss out from any topic in this series. So I'll bet if you can cover from the first series to the end, you are a guru already. Now take notes, I'll be dropping it in a playlist, so once you see one, you can see the next video. I'll be arranging it topic by topic to make it very simple for you. All right, so also note that at the end of each video I drop past questions, exam past questions on each of the topics. So at the end of this video there is a past question. The first video on this series, past question is at the end. This video also, past question on this topic is at the end of this video, so watch till the end. Let's move on to physical and chemical changes. All right, now let's look at the physical changes and chemical change. Physical change and chemical change. Now, number one, in physical change is easily reversible, while chemical change is not easily reversible. I want you to visualize this. Let's look at physical change as conversion of ice, that's solid, to water, liquid. Conversion of solid to liquid, ice to your liquid water. You can say that it is easily reversible in that you can actually solidify the liquid back to ice. So you can say that physical change is easily reversible. Now chemical change is not easily reversible. Take for example burning of paper or burning of wood. If I burn this paper now, this book, can I put the ash, the gas and everything together to get back this book? It's not possible. So you see that chemical change is not easily reversible, but physical change like that of water to ice is very easily reversible. That's one. Two, in physical change there is no new substance formed. No new substance is formed. Ice to water. Water is still water, ice is still water. Do you understand? So there is no new substance formed. But in chemical change, new substances are formed. Still on our example, if I burn this book, the new substance is formed will be what? Ash, gases. You see? So you can see that a new substance is formed. We said two things. No new substance formed here, new substance is some in chemical change. This is not easily reversible, this is easily reversible. Now number 3, there is no change in mass of substance. If you want to try it after watching this video. Measure the mass of ice. That is, measure the mass of ice. Then allow it to liquefy. Turn it to liquid. Turn it to liquid. Now, after turning it to liquid, that is, melt it. After melting it, what do you notice? Measure the mass of the water. You see that it's the same thing as that of the solid. So there is no change in mass of substance under physical change, but there is always a change in mass of substance under chemical change, because the mass of the gas and the mass of this paper, the mass of the ashes and the mass of this paper, this book, will not be the same again. Do you understand? I hope you are following. Now in physical change also, no great heat change occur, while in chemical change a great deal of heat change occur. Here you require a great deal of heat in chemical change. By physical change, the only heat required is called latent heat. Latent heat is just the heat that is required to change that solid to gas, to liquid. If it's solid, if it's a melting of ice we are talking about, no great deal of heat is required. But for you to burn this paper, a great deal of heat is required. So these are few differences between physical changes and chemical changes. Take note of them. Very, very important. Now, very quickly, the last thing here is the properties of matter. Now, properties of matter can be grouped into physical properties and chemical properties. So we have physical properties of matter and chemical properties of matter. Physical properties of matter are those ones that are associated with physical changes, which we just looked at. While chemical properties of matter are those ones associated with chemical changes. Physical properties of matter, example, color, odor, those things you can actually see, you can actually visualize and also. Now color is a physical property of matter. Odor, taste, density, boiling point, melting point, solubility, hardness, malleability, all those physical properties. These are physical properties of matter. Now chemical properties of matter are associated with chemical changes like rusting of iron, burning of paper, decomposition, and all those things. Do you understand? Chemical properties deals with chemical changes like rusting of iron, that's corrosion, burning of paper, and others. Now, based on chemical properties of matter, matter can be classified into 3. Based on the chemical properties, matter can be classified into 3: elements, compounds, and mixture. Elements, compounds, and mixture. In our next video, we are going to treat elements, compounds, and mixture in details. Now we move on to the past question on this topic. Just like I said earlier, at the end of every topic we treat past questions. So let's move on to the past question. But before then, if you've not subscribed, please click on the subscribe button. If you have any question, drop it in the comment section. If you have any observation, anything you want me to improve on, drop it in the comment section. If you don't have anything to say, at least say thank you in the comment section and subscribe. Like this video also. Let's move on to the past question.
Say your answer loud as you answer. Question number 1. Which of the following best describes matter? The correct answer is B. Anything that occupies space and has mass. Next question. Question number 2. Which of the following is not a state of matter? The correct answer is C. A. Question number 3. The particles of a solid dash. The correct answer is C. Vibrate in fixed positions. Question number 4. The process by which a solid changes directly into gas is called. The correct answer is B. Sublimation. Question number 5. When water vapor cools and changes into liquid, the process is known as. The correct answer is A. Condensation. Which of the following is a physical change? The correct answer is C. dissolving sugar in water. Question number 7. A chemical change is always accompanied by dash. The correct answer is C. Formation of new substance. Question number 8. Which of the following is a chemical property of matter? The correct answer is C. Reactivity with acid. Question number 9. Which of these is a physical property of a substance? The correct answer is melting point. Question number 10. When iron rusts, what kind of change occurs? When iron rusts, what kind of change occurs? Drop your answer in the comment section, and if you're not subscribed, please click on the subscribe button. See you in the next video.